Hello all. In this tutorial we discuss about 8255 programming. This is another lesson, but in this programming the difference is that in this programming technique we used 8 LEDs which is connected port A to port A7, and some switches are connected from port B0 to B7. So now see that this is a pull up switch or push down switch, because if the switch is push then the logic 0 is present here, okay, because these are resistance connected, either 10k or 1k is connected to plus 5 volt or plus VC, and when the switch remains open there is logic 1, and if the switch is closed then there is logic 0, and if the switch is pressed then the corresponding LED, that means if S1 switch is pressed then LED number 1 is glowing, and 2, 3, 4 and so on, okay. So depending on the switch position the LED pattern will be glowed. So this is the programming, our first approach. So now what is our task? Our task is first calculate the proper address line, okay, or address value. So now we know that from A7 to A0 again there are 6 1, because they are A7 to A2 connected to high NAND gate. When this is low the IC will be selected, and the lower two address A1 A0 are connected by this line. Say for here A1 and A0 are connected. This A1 A0 used for, if this is 0 then this is port A, if 0 1 then port B, if 1 0 then port C, and if 1 1 then CWR. So what will be the address? That address of port A will be FC, and the address of port B will be FD, the address of port C is FE, and CWR address is FF, okay. So this is the address, corresponding address for the corresponding port. So now our second step is initialization of CWR values. So what is the CWR values? So we write here. So these are D7 bit equal to 1 for input output, D6 D5 equal to 0 0 for mode 0. The D4 bit is a port A, here port A uses output, so this is 0. D3 bit is used as a port C upper, so this is basically don't care. This is port B0, that is port B used as a mode 0, so this is also 0, and this is used as a port B input output port, here port B used as input because switch are connected, and last bit is a port C lower, so this also don't care. So the logic is this is 0 0 1 0. So our logic is this is 0 and this is also 0, so this is 82 hexadecimal. So now our third step is to write the code properly. So now first we store this value CWR value in the accumulator and out to the CWR address to initialize the port A used as output and port B used as input, okay. And then after this we use in instruction, because we read the switch status from the port B. So what is the in address? In address is FD, okay. After in, the what is the operation of in? The operation of in is to store the data from the port address and to store in the accumulator, okay, and then it out to the port A address. So what is the port A address? FC. Now out means the accumulator data is transferred to the corresponding port, that is this is a port A address, okay, and this is FD means port B is read and port A is write. So now this is, here we used instruction say jump L1. This L1 should be here, because this program is infinite times, because user press switch anytime, so that's why you used here loop programming, okay. That's why you use here unconditional jump, again in and then out here. So when any one switch is pressed, then the first of all, if no switch is pressed, the logic status is 1 1 1 1 1 1 1. So this is the status. So say this is switch 1 and this is switch 8 from S1 to S8, and this is LED 1 and this is LED 8. So now here this is L1 means LED number 1 and this is LED number 8. So now if any bit is 0, say this is 0, so now the corresponding LED, the corresponding data bit is in the accumulator is this. So now when this accumulator data is sending via out instruction this out instruction, okay, fc, this instruction, then this data is transferred to the data bus, that is via this data bus. I show here, this is the data bus, and it internally connected to the port A. So now it will go to the port A, and LED 1 will be glowing, because this is a common anode connection, because P type is connected to the plus VC of the LED and N type is connected to the port A. So now the LED is glowing. So for any switch status, say for this switch will be 0, okay, now say this switch will be 0. So now this bit equal to 0. So what is a bit pattern? So this is a bit pattern. Now LED 1 2 3 4 5 6, L6, LED number 6 will be glown. So this is a programming approach to press the switch, and the corresponding LED will be monitored which switch will be pressed. So this type of programming is used for automation or any process control or any PLC type of programming. This type of, where any switch pressed, there is an indication that this switch is pressed using this assembly language or any higher level language like a C also, and these code will also be used for 8051 peak programming, AVR programming, okay, because that disadvantage of 8085 means the lots of hardware requirement here, because instead of 8085, if we used 8051 there, then the hardware complexity is more less, okay. So that is the advantage of microcontroller over microprocessor. But here today we only discuss about the microprocessor programming, so that's why we discuss about this 8255 features over connected to 8285, and how to read the switch status and sending the switch status to the corresponding port. Okay, that's all for today.